Hello students, this is Mr. McAllen, and today we're going to be going over solving equations and inequalities in one variable. So before we start that, we should be able to make sure that we can verify a solution. So there's an equation that we start with in example 1 where it says 2x squared plus 5x equals 3. And we're being asked, is x equals 3 a solution, or is x equals negative 3 a solution, or both? So what we want to do, let me just make a little correction here. What we want to do is we want to just plug in 3 and see if the equation is verified. So you just simply plug 3 in. And if it equals 3, then it works. But clearly this first equation, we have something plus something is going to equal 3, and this is going to be pretty large. So we have 2 times 9 plus 15. Is that going to equal 3? And then we have 18 plus 15. Clearly this is going to be larger than 3, so this is not a solution. So let's try it again, but with negative 3. So I'll just put negative 3 here, put negative 3 there, and now this part will still be 9, but this part is going to be negative 15. So then we go about and we try to, so we do 18 minus 15. We have 3 on the left, and that equals 3 on the right. So the second is a solution. All right, so that's great. So now we move along, and we're going to look at solving a linear equation in one variable. So in this equation, the directions would say solve for y. We should always verify our solution afterwards by plugging it back into the original equation. So when we solve this, the left side is pretty straightforward. I'm just going to repeat that. But the right side, we should multiply the 2y through. And this is using the distributive property of multiplication. 2y plus 8. As a teacher, most people would be looking to see if the student left that to be 4 or 8. And if they left it to be 4, that would clearly be the student did not distribute. Now I'm going to solve for y. So I'm going to, I'll leave the 4 on the left, only because I want to put the y's on the right side, because I see if I add 3y to both sides, my y quantity stays positive. You don't really have to do that. But I'm going to have 5y plus 8 is equal to 4, and I'm going to subtract the 8. So when I subtract the 8, I'm going to have negative so then that's going to give me negative 4 on the left, 5y on the right. So in solving this equation, y will equal, I'll divide by 5. So y will equal negative 4/5. So I should check that to make sure that's right. So 4 minus 3 times negative 4 over 5, does that equal 2 times negative 4 over 5 plus 4? So I'm just going to do the arithmetic on this real quick. I'll pause the video so I don't waste your time, and I'll check back with you in a second. So I solved the problem. I found out that x was equal to negative 4/5. I plugged in the value into the original equation, and upon solving it, on the left side I got 6 2/5, and on the right side I got 4 12/5, but that simplifies to be 6 2/5 as well, so the solution works. Now let's work with solving a linear equation involving fractions. Now a lot of people don't like fractions, but we have to be able to solve these types of equations as a prerequisite skill. So we notice that we have a denominator of 4 and denominator of 8. If we multiply by the least common multiple, which would be 8, so everything gets multiplied by 8. The left side and the right side, we can get rid of those fractions. So on the left side, we're just going to have 5y minus 2, because that 8 will cancel that. As long as I do the same thing to the left side, multiplying by 8, as I do the right, I could do this. So then I distribute the 8 to both fractions. So that's going to equal 16 plus 8y over 4, and then that simplifies to give me 2y. I'm going to subtract, I'm going to combine like terms, so I'm going to combine the, I'm going to subtract 2y from both sides, and then we have 3y minus 2 equals 16, and then I'm going to add 2y to both sides, and then look, it works out to be a nice easy number. Y will equal 6. So you should always plug it back into the original. So I had 5y minus 2 over 8 equals 2 plus y over 4. So it should work in this original equation. So if you plug 6 in, we should get the same value. So here we'd have, plugging 6 in, I'd have 28 over 8, because plugging 6 in gave me 30. And on this side I have 2 plus 6 over 4. This fraction turns out to be 2 plus 1.5 or 3.5, where this side turns out to be 8 goes into, so it goes in 3.5 times. So it goes 8 times 3 gives me 24, a half a time gives me 4, so it checks out. Last equation for the lesson, solving a linear equation, or I'm sorry, a linear inequality involving fractions. So with this equation, I want you to pause the video, and I want you to come up with what is the multiple you want to multiply both sides by. So the first step would be multiply by some value. So pause it, and then when you come back, you'll see the work that I do on it. So we're back. Hopefully you paused the video and you tried to figure out what to multiply by, and 12 is the value. 4 times 3 makes 12, and on the other side, even though it was 6, 12 is the common multiple between sides. So now you distribute the 12. And distribute the 12 here. And now we can, now I'll have 4x, because I simplify this fraction, plus 6 is greater than 3x plus 4. And now I'm just solving it as if it was a linear inequality. I'm going to subtract 3x. I have x plus 6 is greater than 4. Now I'm going to subtract the 6. And I have negative 2. So my solution is x is greater than negative 2. So now, if I had to describe this with interval notation, let me spell that right. I would just use x is on the interval from negative 2, because it's greater than, up to infinity. And I would use an open bracket there because it's greater than. Okay, well, hopefully this video helps, and tomorrow we'll be working on more problems in class dealing with these types of problems. Have a good night.